Welcome to Data Innovation Summit 2020. I'm here at another tech news session with a guest from Snowflake. Please feel free to introduce yourself.
So hi everyone, my name is Stellwall. I work as a senior sales engineer at Snowflake. So I'm going to spend the next 20 minutes to talk to you about, well, Snowflake as a data platform and show you what it can do. So let's
Awesome. So why don't you give an introduction to Snowflake? Not everybody has, I think many people have heard the name. You guys sure have had a presence at many of these events, but maybe many people haven't had hands-on experience with it and know what's different about it. So please tell us.
Yeah, so let me start off by giving a short introduction presentation. So I'm just going to show you a couple of quick slides, just to set the scene. So Snowflake is what we call a cloud data platform. Is built for the cloud and it lives in the cloud. It is cloud agnostic, so we run in Google Cloud, Amazon, Azure, and we can run across clouds, and regions in that sense. The focus we have is to manage your data and enable you to use that data primarily around 6 different workloads. So optimizing your data engineering tasks, your pipelines, using your data in a data lake manner, using it as a data warehouse, supporting your data science, and allow you to build data applications on top of your data. And then we also have features and functions that I'm going to show how you can share your data and make it available through your organization, but also to third parties, and also how you easily can use third-party data, which is a kind of an important part of your data management. And finally, just showing the architecture to say what is unique about Snowflake, why does our customers and partners like us so much? And much of the secret sauce is in the architecture, how we are built up. So we have what we call centralized storage. We gather data logical in databases, but we're utilizing the storage mechanisms of the underlying cloud we're using. And this is central. We store data only once. And on top of that, we have a compute layer. Now, a lot of solutions talk about the separations of compute and data. And we have a true separation of that. That means we have different type of compute shapes we work with. We call them virtual data warehouses, but you can see it as instances or clusters you can run. And each of these clusters can run independently of each other against the same data. So what we manage with that is a kind of a separation of workloads. So you can do your ETL at the same time you do your BI and analysis without affecting each other when it comes to performance. And we can scale up. So you can grow up once you need more power, but we can scale out as well to support concurrency usage. And on top of that, we have what we call our cloud services that is managing transactions, security, metadata. So we capture metadata about all the data we have and the usage of the data, so we can use that in smart ways, and also sharing and collaboration. So this is a very high level, quick introduction to what Snowflake is. But seeing is believing, right?
Right.
So let's see if I can manage to show us more about how Snowflake works. So what we have here is the standard interface you get. So Snowflake is a service. So you can see Snowflake as something like Salesforce or ServiceNow. So you don't need to do a lot of configuration when you start it. You get your account and you log in, and this is what you get. And within this, you have your databases. So as I said, this is how we logical store gather data around. But it could be, it's not just relational data. It could be semi-structured data as JSON and XML as well. And then we have the warehouses, which is our different types of compute that we work with. And I can have multiple of these, and you can see they have different sizes. So when I create an instance, I give it a name and I gave it the size. And you can see this as, since we all have t-shirt sizes. So we have everything from extra small to 4 times large. And for every size, we double the capacity of what we can do. And I can grow this up and down instantly if I want to. And I also set it up for clustering, so to handle concurrency. So the bigger the instance we don't get more concurrency, we just get more power to crunch data. So if we want to have concurrency, we need to have scale out and have more instances to work with. So we can work with that with clusters. So we can have up to 1 to 10, and we can automatically scale this. So once it gets more queries, it will spin up additional clusters for me.
Can I ask a question? You mentioned that you can both scale up and scale out. Is it equal? And with many vendors, it can oftentimes be easier to scale upwards but not downwards, or outwards but not inwards. So given that this is a nice opportunity for cost efficiency, being able to scale out and back, is it equally easy to scale back if you've done some end of the year calculation and then you want to scale back after all that's done?
Yeah, absolutely. It's a good question, and this is something that is built from start. This was the focus. Since this is cloud, as you said, we want to be effective and we want to be cost effective. So you can scale up easily. It's just a command to say, well, change the shape. But it's the same command to say, well, change it back to a smaller size. So you can do that.
You don't have to reshuffle data and do like a long process to be able to scale out and scale back?
Yeah. So and the scale out is the same. So if I set it up and I have a policy in how it's going to be scaling out, the standard policy is once it's starting to queue queries, it will run more clusters. And then once these queries run out, it will scale down automatically for me to my original, what I say, the minimum clusters I want to have for this. But we also have features like auto suspend, which is also important to say, well, if this instant compute is not used for 10 minutes, shut it down.
Right.
Automatically. But also, if I send queries against it, start it for me automatically. Mm-hmm. So I don't need to do this all admin, you go in, shut it down, and then I realize, okay, I want to run some reporting. I have to start it again and remember to shut it down. We take care of this automatically. And I mean, during times like these with Corona and everything, when people are downsizing, our customer love this feature. So we can see that they can stop using and don't have to pay for it, which is great in these type of things. But you don't also have to be afraid that you have something big running and you forget about it. So let's just walk more practical. I have loaded some data today in a database, but you can also see here rather quickly is to say, well, this is how I scale up to say, well, set the warehouse size to large. Then I have a command here where I load the data. I've already done that, and then I scale it down directly afterwards. Mm-hmm. So that's all I need to do. So I preloaded about 100 million rows for us. This is city bike data. So the bike sharing organization in New York, they make their data public available. Mm-hmm. So we can download it and use it. So we have some basic data around trips. So you can see that how long took the trip, when did it start, when did it stop, what is the starting station, the end station, the bike ID, and so on and so forth. And of course, we can analyze the data. We speak SQL, so everything is 100% SQL. However, one of the challenges for me is I'm a kind of a visual guy. So for me to look at data in this way in tabular is making life a little bit hard for me to understand if this is good, how is the distribution. So we're talking about new things in Snowflake. So something we released recently and is rolling out now is a new interface called Site. And Site is a more visual interface that I can work with what we call worksheets. I still write SQL. The difference is that I get auto suggestions. Mm-hmm. So I don't need to be fluent in SQL in order to write things. It also keeps tracks of, my databases and my tables I have access to. So I also can get these type of things for me, and I can then run that and get some answer. Mm-hmm. However, when I do my analysis or my data understanding, I want to know a little bit more of my data. So we can run queries and we will get the result as we see. We also provide some additional statistics in this that helps you to see what is the distribution of my data based on the data set I got the return for. And we can basically quickly select part of this data. Now, one thing that I like with this is that once we retrieve the data the first time, we don't go out and ask for it when I do these type of selections. We're using the same cache data. So we actually don't use my compute resources.
Right.
So there's no charges for me when I'm doing this.
So if you've already filtered it, you don't have to filter it again to do an additional query on the filtered data.
Yeah. So when I'm using these type of filtering, so I can clear my selections, I can download it here as a CSV. But maybe what is more interesting is also we provide charting capabilities. So in the same way as some of the notebook GUIs like Zeppelin is doing, I can use charting here. So it gives me a line chart, for example. We don't have that many. We have a number of the more commonly used like bar and scatter and heat grid and scorecarding type of charting. But it also allows me to interact with it. So I can say, well, I want to do, instead of a sum, I can do an average. And once again, it doesn't recollect data. It's using the same result. It's doing everything on the cache for me. I can even also change the way how I'm bucketing the data. So it sees that my data for example, the start day is a daytime, and then it gives me possibility to say, well, I want to watch this on a month level instead, and I can do this. Once again, we don't collect new data. We're using the same result as you have. And we can see, and I can get some information. I can see that it's a highly seasonality on this data. I can see that there's a increasing trend until we were hit by Corona, and everything goes down. But for some, it seems like in New York they are starting to relax and using bikes again. So it's on the way up. And another part of this is I can combine these worksheets and what we call dashboards. So if I want to have a more combined picture of this, I can do the same thing. So this is just worksheets that I'm combining here and putting together, and I can share this within my organization with people using the link so they can go in. Now, this doesn't have all the capabilities that you would find in Tableau and these type of tools, but it's really helpful to get a start and understanding of the data before you decide to do your BI tools or something else on top of it.
Right. Let me ask, I really like the notion that you had t-shirt sizes when it came to the nodes. That analogy is cool. Are the t-shirt sizes the same no matter what cloud you're on, so that you have a sort of a Snowflake t-shirt size? And that's sort of nice. That makes it easy to, to talk about them. I'm curious, now you're making queries and it's redrawing things and it's sort of interactive. I think that's an important function in a tool that a data scientist uses, so you don't have to run a query and then come back 15 minutes later and hopefully what you intended comes out. There needs to be a level of interactivity. How should people be thinking about t-shirt sizes and the amount of data that they have in order to get a level of interactivity that's fun to work with? So you said, I suppose this is the 100 million row data sets.
Yeah.
What kind of things should people keep in mind? What kind of data sets can Snowflake handle comfortably?
The sky is the limit, I would say. I mean, I think when it comes to sizing, it is always the as you said, how the level of interactivity you need. So how quick do I need to have my results back versus, well, what is the cost for that? Because I mean, you consume compute, so you pay for usage. We charge by the second. So if you use it for 13 seconds, you pay for 13 seconds. If you use it for 5 minutes, you will pay for 5 minutes. So you have to take that into consideration. But I mean, if it's something you need to do quickly, well, then you might want to have a bigger size. But I'm doing this on a small size warehouse. So I'm not using a very big one. The way how we store data and distribute data makes it very efficient in selecting data. You don't create indexes either as a user for this. Okay. It optimizes it's by itself. So you kind of have to test your way through. For example, when I loaded this data, I was using a large instance, and it took me about 10 seconds to load 100 million rows. So it's very efficient. And of course, then you have with the cluster size, it depends on the concurrency you need to have. how many is going to do this at the same time. But we also have functionality within this within this UI, so I can set it up to say that I want to have it to do notifications. So if I have long-running queries and I don't want to have them fast, it is okay. It takes me 5 minutes to crunch. This is 10 minutes. It can interact with Chrome to give me a notification once the query is finished. So I get an alert in my browser that now is the query finished. I can go back. So we also provide functionality for that in that sense. So this is a little bit quicker on the dashboarding and that type of functionality we have. We were looking at trips data, and it would be nice to be able to combine that with third-party data like weather, because there's probably some correlation and causation between the type of weather we have and how many bike rides is going to be done. So what we have in Snowflake, we recently launched something called the Data Marketplace. And the Data Marketplace is a way for you to get third-party data. So different organizations and companies can publish data here that I can use together with my own data. So you have within different types of data, like demographic data, we can have some government data, and so on and so forth. We have, for example, in this case, we have weather data. So if I were interested to use my trips data with some additional weather data, I don't have to go out and grab that data for myself, scrape, or using API. I can go into the marketplace and I can find it and say, well, there's a weather source here that has global weather data. It gives me example how I can use it. And I can just click on get data to get it and use it. But it doesn't copy data. It just enables me to use the data.
Right. And I suppose you have internal enterprise data stores as well, so that you can both import public data sets and your corporate data sets.
Yeah, but you don't import it. And I'm going to show you later on how you use it, because it doesn't move. I mean, other types of data marketplaces that are out there, they have APIs that you have to call to grab the data. Mm-hmm. But the problem is, once the data leaves the marketplace, it is as it is, and you have to grab it again to update it. In this way, this is just going to work as a regular database that you have in your Snowflake account. So if the provider updates your data, the data you use is automatically updated as well, because you're using the same data.
I see.
So you don't have that. You don't have to move it around. You don't have to pay for that storage either, because it's not stored on you.
Right.
This data is available in a different way. It could be free data, but it can also be subscribed data. So I, as an organization, if I have interesting data that I want to monetize, I can use this function to be a provider to say, I want to sell this to others to use.
Right.
So this is a good way. But we also provide, as part of this, a way for you to share this in more of a private manner, because everything, if you get a provider on the data marketplace, it's globally available. Everybody that has a Snowflake account can see it and can use it or subscribe to it. So we also have something we call a data exchange. And the data exchange is a way for me to privately share data within the organization or with my customers, suppliers, or anyone else I want to do. So for example, within Snowflake, in the pre-sales community, we share data with each other. So example, the demo I'm showing you, the city bike, all the assets for that is shared. And we also provide internally weather data. So I can go here and say, I want to use this weather data because it's already prepped for me. And same as the marketplace, I say, well, get data. I want to have it as called it weather in my instance or in my Snowflake account. I need to accept the terms. And now I can create, I have created this as a database, but physically I haven't moved anything. The only thing I make this is logical available for me.
Right.
So I have now a new database. So if I go back to my original GUI and I do a refresh, I can see suddenly I have a database that says weather. It has a little bit arrow, and the arrow says to me, this is a share. So this data is not local, it is outside, but I can access it as normal data. So if I want to query it, I can do it quite easily. So I'm just going to set some context. So I'm using the right roles, and I'm using the right warehouse around this. And give it some rights. So if I select from this is my weather share. So I just select from it, so we can see here's the weather data. I have temperatures, I have if it's rain, how much rain it is. Everything is in Fahrenheit and inches. This is American, and we're in Europe, so we want to do Celsius. So I can use this data the same way I use my database data. So I can create a view on it. So now where I do my conversions, so I can convert this to millimeters, and I can convert this to Celsius degrees, and I can work with this view. So the view is now stored locally for me, so nobody else sees this view, but it's using the same data, and I can actually combine it with my own data. So I can join this with the trips data I have that is locally stored for me, with the weather data that is stored outside my account. So we now combine this third-party data with additional data, with our own data easily without having to move data. Mm-hmm. So once I get more trips and they get more weather data for each new day, I will see those changes immediately. So I don't need to create some kind of pipeline to reload or update from my external source. So if I was scraping weather data by myself or buying it from a weather provider, I would call an API every day to get the new weather data. But this, as soon as the provider has updated, it is updated for me.
Right.
And the same way, if I share internally or I share with other organizations, if I say, well, let's share my trips data, if I update it, it will go through to all others.
That's pretty neat how by design it sort of facilitates these processes and data pipelines just by the virtue of how Snowflake is designed. Does that mean that Snowflake is main strength is in OLAP processing, or is there OLTP capabilities sort of in the background? What would you see as its main strength?
The main strength is OLAP. That is where we have started and what we've been focusing on currently. But of course, who knows what's in the future? But that is where we have the strengths now in analyzing vast amounts of data and using it in various ways. That is what our customers using it for.
Okay, so for like the C-level decision makers now, what would you say is the standout feature of Snowflake? I think we can talk about neat schemas and neat user-defined functions and whatnot, but if you want to summarize it for the C-level people, what would you say is a standout feature, the one-liner?
Yeah, it's a good question. I think one thing that C-level likes is just this data sharing, the data monetization. That is something that I find very interesting in how we can make data available for others. We have customers like Cisco that provide data for their suppliers in this way, and using that, but also the around how you pay for what you use. So we truly just charge you for usage. You have a fee for your storage, which is basically a flat fee based on whatever the cloud provider is charging you. Mm-hmm. So it's about on an average about $23 per terabyte per month. So that is the fixed cost you have, and then we charge you by second for the compute. So C-level loves that you have. I mean, you only pay for what you use. That means that if we have downsizing times like we have now, and we send home half the staff or almost everyone, and we have nobody's using this, well, it doesn't cost anything else than storage. So that is something that they like a lot of this. It is also, I mean, how easy it is to use. Just load the data and start querying. So I don't have to set up things. I don't have to maintain or optimize and doing these type of things. So you get started rather quickly and you can grow as you go in that sense. I think that is something that appeals them a lot. It doesn't take 6 months to get something running. You do it in hours and days instead.
Nice. All right. Well, that was a really neat introduction. I feel like I've learned more about Snowflake, and I hope the audience took notes while you were presenting today. Thank you very much for your time, and please feel free to to contact Snowflake if you have any more questions about what was shown today, and I will be seeing you at the next session.